Welcome to Wales Tech Week 2021. Thank you to our partners. Enjoy the session.
Good morning, all. Welcome to our session with Welsh Water and Costain about hydrogen supply and demand. I'm Ben Burggraaf. I'm the head of energy for Welsh Water, and I will be co-presenting this presentation together with Gareth Davis. Gareth, do you want to introduce yourself?
Hi, I'm Gareth Davis. I'm a consultant working on decarbonisation at Costain.
Good. So the way we're going to go through this presentation is that Gareth and I will be sharing this session. I will start off with providing some introduction, and then we'll leave it then to Gareth to talk a little bit more about the detail and the work we've done to date. And then we'll round up, I think, the conversation later, and then we'll go over into some questions and answers. Hope you'll enjoy. If we go to the introduction slide, Gareth. The way we're going to build up this presentation is that we're going to talk about a little bit about Welsh Water and provide you a little bit more background about our decarbonisation strategy and how this project actually fits into the wider context. Also, Gareth then will talk about the alignment with the Welsh government kind of vision and also a little bit more detail about what is actually HyValue, and talk about the work they've done to assess the hydrogen demand in the local area. And then I will round up the conversation with some conclusions and what we're planning to do next. If you look at Welsh Water, we actually launched our decarbonisation strategy only a couple of weeks ago. Welsh Water, for people who don't know the company very well, is actually a not-for-profit utility company. And instead of having shareholders, we have members who hold us to account, and all the profits we make, we normally go to shareholders, are reinvested back either to lower bills or to accelerate investment within the company. From a carbon strategy point of view, we announced recently our new targets. We want to be 35% energy self-sufficient by 2025. We're currently at the 25% level. And we want to achieve a 90% reduction in our total carbon emissions, and that's not only operational, but it's also our embodied carbon in our quite extensive construction program to upgrade and replace assets by 2030, and then achieve carbon neutrality, full carbon neutrality. So there's included embodied carbon by 2040, or better, or earlier if we can. And achieve 100% energy self-sufficiency by 2050. The key improvement activities which we have to undertake is, first of all, encouraging our customers to use less water. The less water we use, the less stress we put on our systems, less water we leak, the less it also costs to pump water. So all those kind of things are key enablers to reduce energy consumption and actually become more resource efficient. Measure and control nitrous oxide emissions. We emit quite a lot of NO2 and methane by bubbling air to treat wastewater in our wastewater treatment works. And one of the key activities we have to do over the next 10 years is start measuring and controlling them better than the current uncontrolled release of these emissions. And they're currently the largest single operational carbon emission within our carbon footprint at the moment. Prioritize biogas to decarbonise heat and transport. This is pretty much, I think, one of the areas which talk about a little further, and our project aligns to, because we believe that using biogas to decarbonise heat and transport has a 3 to 5 times larger societal impact than the way we're doing that by converting it into renewable electricity. Replace fleet with vehicles that utilise low carbon fuels and or electricity. Apply the carbon mitigation hierarchy within the capital program and really look at nature-based solutions to treat water at source rather than the conventional methodologies. And lastly, increase carbon sequestration of our land holdings to offset remaining emissions, which are either difficult to abate or not cost effective to abate. So for more information on our carbon strategy, head over to our Welsh Water site, which is doorcom.com/net-zero, and there you can find a little bit more information on how we plan to tackle our emissions. Can you move over to the next slide? So within their journey to net zero, we have a couple of key strategic principles, and building on all the work we've done year to date, which has achieved a 65% reduction in our total carbon emissions since 2010. Firstly, we want to continue the good work we've already been doing on reducing energy consumption, increasing self-generation, and sourcing remaining electricity from Welsh-based renewable generators. And particularly, they need to be REGO-backed and from a credible source. Secondly, prioritize the use of sewage-derived biogas to decarbonise heat and transport, rather than using it to generate renewable electricity. As said, it has a 5 times larger decarbonisation impact by 2030. Now the grid is continuing to decarbonise. Gradually replace the existing fleet with vehicles that use either hydrogen, biomethane, and/or electricity. And actively control and reduce the fugitive emissions, as said earlier, and we'll need to monitor and reduce the emissions associated with the construction activities, which is significantly. Welsh Water spends over a 5-year period about £1.5 billion, and a large of that is in concrete and steel structures, which has a large carbon emission associated with it. And then lastly, as I said earlier, the maximizing the carbon sequestration potential and biodiversity of our land holdings. We're a large landowner in Wales, and we can do more as a company to improve the level of carbon that is removed from the atmosphere from those land holdings, and improve the biodiversity in those areas. We move on to the next slide. So we worked a couple of probably 18 months, 2 years ago now, with the Hydrogen Wales Trade Association. We had a meeting with all kinds of original equipment manufacturers and other stakeholders, and we discussed what we will be able to generate, how much hydrogen we possibly could generate from 35 gigawatt hours of biogas. This is the amount of biogas that was available at that time, and we couldn't utilize the full adequate sludge capacity within one of our treatment works. That was a number which we used to initially conceptualize the idea. And we worked, as said, with original equipment manufacturers like Biotech, Nanosun, and a couple of other companies, but also local supply chain partners to develop this idea further, which also then was supported by Costain and other partners. Move over to the next slide. So this meeting then turned out to be surprisingly coming out with a larger volume than we thought we would get from 35 gigawatt hours of gas. And we ended up, instead of discussing it initially at one of our sites close to Dinas Powers, relocating the kind of idea to our Cardiff East wastewater treatment works, which treats adequate wastewater for over 1 million population equivalent, and is our largest power consumer within our company. And we're using that 35 gigawatt hours of hydrogen, we came up with the number that we could generate up to 2 tons or 2,000 kilograms a day of hydrogen and green hydrogen, by using a steam reformation technology, and by implementing that on Cardiff wastewater treatment works, we would be able to generate enough hydrogen suitable to supply 100 buses or similar every day. And due to the quite good location of the treatment works being in the docks area, quite close to the Veolia waste incinerator, quite close to the Lambie Way refuge collection vehicle depot, we started to talk with Cardiff Council, particularly on looking at this from a decarbonising refuge collection vehicles, but also enable bus decarbonisation and other forms of transport, including Welsh Water's HGV fleet, which actually ferries sludge around to be treated at the treatment works. So that location at Cardiff is a really good kind of like central location. Now, if you look at the net benefits of this commercial scale kind of demonstrator, we could save well over 9,000 tons of CO2 equivalent, and that is not far off the total transport emissions which we report in scope 1 and in scope 3 within our business. So this single kind of investment would make Welsh Water's transport almost virtually net zero. So that's a significant impact. But not only that, we believe that the introduction of using hydrogen to power fuel cell electric vehicles could also reduce a significant amount of PM10s out of the local atmosphere and significantly improve the air quality with close to 140 kilograms per year of PM10 being removed as a result of this project. We also think that it will attract green jobs and attract new businesses to the area and make Wales potentially a hydrogen pioneer alongside the work which has already been done by University of South Wales with their hydrogen centre close to Baglan near Port Talbot. But there is also potential for rollout of this technology to other Welsh Water sites where we also have advanced anaerobic digestion processes like the ones near Port Talbot at the Avon treatment works, Cogmores near Dinas Powers, but also up in North Wales in Wrexham at our Five Forge wastewater treatment works facility. Next slide, please. So if you look at the type of vehicles we're aiming at, we're looking really at powering initially the heavy goods vehicles, which are really difficult to electrify, but also working together with River Simple and other parties on looking at smaller vehicles. This could also be advantageous. So the initial kind of demand from heavy goods vehicles like refuge collection vehicles or HGV tractors to ferry sludge around the South Wales region, or buses could actually help also to kickstart the uptake of more personal and smaller hydrogen vehicles like the ones River Simple is planning to develop and build and manufacture in Wales. So it has advantages for heavy duty because we can have a longer range, but also we can deal with the challenging kind of routes and also the kind of the gradients we see in Wales. And with the electrical infrastructure not reaching all the way into the more remote parts of Wales currently, and also Welsh Water working in those areas, we have seen within our own fleet kind of assessment that there will be a requirement going forward for a mix of hydrogen and electric vehicles to make sure that we can still meet our customers' needs. So this project could really boost that kind of like development of that hydrogen vehicle fleet within our company, but also within the local council and other parties. And I know that Gareth will talk about later, but also emerging response vehicle fleet and others have also shown a keen interest in this. The other big advantage of using hydrogen vehicle over electric vehicles currently is that we can have a significant good range, but only a short refuel. So the refuel will be similar to the experience we currently have with fuel stations like with diesel and petrol, rather than having to wait half an hour to an hour with quick charging, but sometimes even longer than that if you have a slow charger system for a battery electric vehicle. Move on to the next one, Gareth. So, but there also are some key cost challenges. We believe that building the hydrogen facility, which I just suggested at Cardiff, that produces about 2 tons a day or 2,000 kilograms per day or 700 tons per year, enough for 100 buses, is actually commercially viable from the outset and requires relatively little or no subsidies. What is the challenge here is actually securing the demand for the investment. We in Welsh Water, we generally tend to work with a investment kind of window for this type of stuff between 5 to 10 years. And we believe we can do that as long as the supply is there. And currently there is not enough supply to justify the investment in the facility. So what we also tend to do with this project is to stimulate and trying to get the supply up and running. And in that, there are some significant cost challenges, because the cost of supplying a hydrogen vehicle is significantly higher than currently an equivalent diesel a vehicle. So it will have higher investment cost that needs to be covered. But the good thing over time is that the operating cost should be lower, but also there's a longer vehicle life expected. So if you do an assessment across the whole life cycle of the vehicle, you should see a significant benefit by going towards this new low carbon technology. But for us to actually secure an investment from our board on this, offtake and long-term offtake agreements are key. And what we're seeking to get from doing the future pilot work and further work on this project is to get these long-term offtake agreements with potential customers agreed, so we can then finally make that large investment, which is expected to be in the range of 20.
But yeah, as Ben was saying, the costs of the vehicles initially are higher, but the operating costs are largely expected to be similar. So with some initial funding to subsidise the initial costs of the vehicles, we feel
I'm
like
there, Ben.
Oh, hello, you're there.
Yeah, I'm there still.
So to conclude, looking at the context of this, this is a vision for Welsh Government, as you can see from the symbol there. This is a sort of visionary picture of the future, the transition to a decarbonised future that Welsh Government put out, and it does look like an enormously complex diagram. This, which of course it is, because the energy system is complex, and the transitions required are enormous. But having said that, if you just sort of focus in here on the key areas being electricity, natural gas and clean gas being the key providers of energy, and at the bottom here we've got power usage, heating and transport. We just sort of thought about the project we're doing in terms of this overall roadmap to try and align as best we could. So if we just go to the next slide, you can see that by 2025, we think that HyValue, if we're producing hydrogen from biogas and biomethane to provide hydrogen for transport, would cover already quite a significant part of that energy system. And if you look further forward 10 years to blending gas on the gas network, which is currently quite widely expected to happen, then by 2035, you can see the reach of the project, the influence of the project is really quite significant. And this could be, for South Wales, for Wales as a whole, or for the UK. So this is really an important project, potentially, in getting the hydrogen economy kick-started to make a contribution to decarbonisation and to local air quality. There have been consultations and ambitions published by Welsh Government regarding decarbonisation, and a specific one we picked up in doing this project, because we're looking at transport, was that there's an ambition to have 200 fuel cell electric vehicles. Those are buses basically that are fueled by hydrogen by 2030. Now that would have an additional cost of around £45 million, because each of those units costs about £225,000 extra compared to a diesel bus. But as the economy is established, the cost of the bus is expected to fall dramatically, and this is a very meaningful way to go about decarbonisation, because buses, particularly those with longer routes, are really well suited to hydrogen. There's also a high level sort of requirement to think about the infrastructure planning for hydrogen alongside battery electric. A lot of the news is about battery electric at the moment for vehicles, and obviously it is a number of years, 3 or 4 years ahead of hydrogen as a technology, and starting to become mainstream. But we'd just like to highlight that maintaining hydrogen now and developing hydrogen alongside battery electric means that things that don't seem a problem now won't come to light. So for instance, if you're converting a fleet to battery electric at the moment, converting to only a few vehicles wouldn't give you a problem with the probably give you a problem with your electrical connection to the grid, but doing so in the future, when you want to convert the whole fleet to battery electric, could cause you with much bigger costs in terms of bolstering your connection to the electric grid, and could make, in other words, investments in further into the future would look really quite unattractive compared to how they look now. So we think there's a place for hydrogen alongside battery electric for sure. So to move to the HyValue scheme, and I'm just aware of time, we're going to have to skim through this quite quickly, but we came up with the strap line, making your poo work for you, and we really like the idea that the waste biogas from the sewage treatment works could produce hydrogen, and as you see later on, could be used to fuel the City of Cardiff's vehicles from the local fleet of the Cardiff Council. Hydrogen's really a good fuel for being an ultra low emission form of transport, because that will make an improvement on public health by having no particulate matter and lower NOx by using fuel cell vehicles. So we decided we would look initially at refueling primarily for fleet vehicles, but also private vehicles, and come up with a scheme that would could basically handle 2,000 kilograms a day of the hydrogen produced from the 35 gigawatts a year of biogas that Ben highlighted initially. So 2,000 kilograms a day is roughly enough for 100 buses to operate daily. So it's quite a significant amount this facility could provide. So I think Ben's already covered this on some of the benefits, but you can see there's a benefit on decarbonisation in terms of reducing CO2 for climate change, and there's a benefit on air quality in terms of the PM10 reduced. Ben, maybe you'd just like to chip in on this one?
Yeah, can you hear me again, Gareth? I'm back again.
I can hear you. Yeah.
Good. Yeah, I'm more happy to chip in. So I think what a lot of people talk about is that we're looking at the steam reforming of actually biomethane in this case, and biomethane is made by separating the CO2 from the biogas, and then steam reforming, which also then expels CO2. But this CO2 is biogenic CO2 because it's a short cycle and derived from waste materials, which is sewage sludge. And that is different to the steam reformation of natural gas, where you're using fossil fuels to decarbonize. And we are currently already had a good injecting biomethane to the grid at our 5 Forts facility, which has been classed as green gas, and we get a green gas certificates for them, or renewable gas guarantee of origins, which are also ISCC accredited, which is one of the European standards for accreditation on renewable gas. And what we're using in this particular case is then using that biomethane to then further develop it into renewable hydrogen. And that's different to the blue hydrogen, which has been discussed quite often in the hydrogen developing, or where we are looking at physically steam reforming natural gas and capturing the CO2 and put it in the atmosphere. And by doing the same potentially with this particular scheme, we could end up actually being a carbon sink rather than being a carbon emitter, because if you capture also the CO2 as part of the steam reformation of the biomethane, we actually net remove carbon emissions from the atmosphere.
Thanks, Ben. So a little bit of detail on what the scheme consists of, and as Ben said earlier, we've communicated, we've collaborated with technology providers for a range of options for each of these processing steps that you can see in the diagram at the bottom. We tie in, connect into the existing biogas holder, which is currently used to the biogas currently being held to before generating power at the Cardiff East site, and then we would upgrade the biogas to remove CO2, water, and any other trace components such as some sulfurous compounds which could affect the processing, and feed that biomethane, which is biogas without the CO2 and all the nasty bits, into a modular SMR, that's a steam methane reformer unit, which would produce 2,000 kilograms a day of hydrogen. So then we then produce that hydrogen, and we would store it locally before using quite a novel technique to distribute the hydrogen from a company called NanoSun, which could enable us to establish more than one fueling facility, which is quite a nice idea, because you have kind of a mobile library type approach where we could have a facility that could visit different areas around South East Wales, around South Wales, to provide hydrogen on, say, on different days of the week. So in terms of the current status of the project, and we having produced a concept design where we produced a capital cost and an overall program for what a project might look like to fully engineer and design and construct this facility. We've gone through a feasibility study, which was part funded by Innovate UK. We've looked at both the supply and demand side, as we'll come on to in a second, because we've looked at the demand side with the Cardiff Council. But significantly, I think this is a real project. There's a lot of sort of movement in the hydrogen space at the moment, and a lot of reviews and a lot of assessments of what the best thing to do is. But this is actually a real project, and I think Boris Johnson used the term oven-ready project recently, which has become a bit of a buzzword, which means that it's a project that is just ready for investment, really. So that it is a viable project economically and technically, and we're looking to move it forwards as quickly as we possibly can. Now, having sort of achieved that financial and technical feasibility, we sort of start to think more deeply about the demand side of hydrogen, and Cardiff Council, who were a really key stakeholder in the initial phase of looking at the HyValue facility, we're a very strong stakeholder, really, and picked and identified, along with Welsh Water, that it's really looking at the hydrogen supply and demand at the same time is really key to making progress. And a lot of people talking about sort of chicken and egg problem at the moment, because you don't get the spend on infrastructure because not enough people are buying the hydrogen vehicles, and vice versa, people don't buy hydrogen vehicles because there's not a nearby supply of hydrogen for them to use. So addressing both at the same time was seen as key as a potential project and as pilots going into the future. So with that in mind, and you can see there on the left hand side, we got some good publicity from the BBC website as well, to sort of promote that, or highlight what a good project it is and what a good proposition it is. Cardiff Council supported us to do a demand assessment, which Costain undertook, looking at overall demand for hydrogen, looking at total cost of ownership, and also funding and procurement options on the demand side. So that means for vehicles, for the infrastructure to provide refueling. So we're now starting to have some joined up thinking, looking at the whole thing as an energy system. If we think back to that initial energy diagram from Welsh Government, a lot of this is about joined up thinking about an integrated system. So we've just finished producing this report, looking at the feasibility of this low carbon pathway, which is using the renewable biogas available from Dŵr Cymru. We've included a financial assessment of the overall cost of vehicles, and we've identified the customer base and the overall market viability of it. So some of the specific tests we undertook were mapping the potential demand for hydrogen, mainly from fleets. So we primarily looked at local authority, but we've also spoken to bus operators, we've also spoken to emergency response vehicles, and we've come up with, with dozens of interviews, online questionnaires, considering different people's opinion, and coming up with a range of scenarios of how much hydrogen could be conceivably consumed in the South East Wales area over the next 10 years. And as you can see there, we talked to all sorts of different people, ranging from bus companies such as Tras Cymru, and First Group and Stagecoach. We talked to obviously University of South Wales were key because they were looking to support us through the HyValue project. You can see we've got a range of, not just bus companies, taxi companies, all the emergency response companies, fire and rescue, police. So we spoke to a wide range of people. Some of them, most of them with a fleet operation. And one of the attractions of fleets is obviously you can talk to relatively few people, but have the influence over a relatively large number of vehicles. So we developed 3 scenarios. I won't go through them in too much detail, but obviously there were varying in levels of optimism from scenario 1, where there's pretty free funding and availability of hydrogen or fuel cell electric vehicles, FCEVs, down to scenario 3, which is a less less optimistic but perhaps more pragmatic view of how things might develop. Interestingly, with the work, we expected to find quite a lot of potential use from buses, and we saw about bus companies expecting somewhere between 40 and 50% of buses in future to be powered by hydrogen. We saw refuse collection vehicles, bin lorries. So you can see in the middle picture there, they were a very strong case for conversion to hydrogen because of the power use, because of all the hydraulic equipment on board the vehicle, and also the fact that you tend to want to have a long shift pattern and don't want to be charging, a battery electric bin lorry for a number of hours during the day. You want them out on the road. And similarly, and quite eye-opening, was the level of demand potentially required from the police force, who saw that hydrogen potentially would be fueling all their blue light services in the future, because they didn't feel like they could respond quickly enough with battery electric. So that was surprising, and obviously for the work we're doing, really pleasing to see. So overall, we developed these curves, and if you could look at the graph on the right there, there's a yellow line indicating the production rate of hydrogen from the HyValue facility at Cardiff East, which Ben and I just described. And under each of the scenarios, you can see that relatively quickly you expect local demand to exceed the supply from the facility, meaning that from a positive point, meaning that there would be some certainty of demand for the hydrogen production facility, and therefore a lot more certainty for potential investment in that facility, which is is going to cost tens of millions of pounds. So although it's financially viable, it does require quite a lot of upfront investment. So the conclusions of that report were that the hydrogen supply scheme has been shown to be viable technically and financially, and we've shown some benefits of the potential for hydrogen demand in South Wales through actively talking to the operators of fleets in the area. And there's proven that there really is a need to develop hydrogen alongside battery electric, both from the supply side and demand and refueling side. And obviously funding for this is going to be absolutely critical. And I'll just pass back over to Ben, maybe to talk through the overview of how we see things going in the subsequent years.
So I think this slide provides a good overview of what we're planning to do next. Hopefully you can still hear me, so there's a bit of a glitch.
Yeah.
What this slide, yeah, okay, good, okay. We are currently have undertaken a feasibility study. We've also had conversations with stakeholders on the design of a trial, and we have been engaging quite heavily with fleet managers, as Gareth already has been indicating. But I think what it really shows that these kind of this project cannot be a standalone project. We cannot look at the production of hydrogen on standalone. We need to look alongside of the demand in order to secure further investment in this particular area. So that's why we have this depicted as a 3 kind of swim lane kind of like a program, of which only the top ones is really in control of Welsh Water and Costain. The other 2 lanes are particularly dependent on what's going to happen, first of all, with demand and decarbonisation being developed within the local councils and other kind of stakeholders, the police, but also big distribution and logistic companies, like, for example, Aldi's and other big companies which are in the local area. And what we really need to understand is what their demand is going to be, but also what kind of vehicles will be available. And I think we need to develop all of these things alongside of each other in parallel. So for next year, we're looking at, I think us, Welsh Water, looking further into the engineering design of the hydrogen facility, particularly looking at what kind of cleanup requirements are there of our biogas, because there's still some constituents in there which could potentially pollute either the steam reformation plant and or the fuel cell electric vehicles. We make sure that we meet that great hydrogen demand in order to make, if possible, be used in fuel cell great vehicles, and investigate funding for trials for undertaking further suitability, to investigate the suitability of certain type of vehicles, but also to ensure that actually fleet managers are happy and also the users are happy with utilizing hydrogen vehicles as opposed to the diesel vehicles they're currently using, or alternatively the electric vehicles trials as they're ongoing. So, and then beyond 2022, we're looking at really stepping up. Of course, subject to having enough support and having enough supply agreements in place that we can look at procuring and constructing and designing the hydrogen facility at Cardiff. Further technology and vehicle trials are needed, but also the availability. We are a handful of vehicles currently available, but there are signals from big vehicle manufacturers that beyond 2024 in particular, these vehicles will become a little bit more available at scale, with big OEMs planning large production or significant up. Also procure vehicles to match the hydrogen supply that needs to happen with our stakeholders, and all of that will hopefully lead, if everything runs smoothly, in the ability to have an operating hydrogen facility by 2024 or 2025. And that means that we can make a big impact now. And what climate change really demands, and the climate emergency, is that we make an impact now. And we believe that this project could have a significant impact on decarbonisation within the South Wales region now, rather than by 2030. And I think it's a great showcase what is possible if we all put our heads in together and all move in the same direction. And we are Welsh Water, we're keen to make that advancement, but we need to have support from all people around us in order to make this happen. And I think that's the end of our presentation, Gareth, isn't it?
Yes, it is.
You have anything else to add?
No, thanks very much. No, I think it's just been really quite an exciting project to be involved with, and I think the fact that we've looked at both sides, looked at the hydrogen and supply and the demand together, is absolutely key for getting the joined up thinking that's needed to really move things forward and actually build something that's going to make physically make a difference for climate change and for air quality.
Okay, I think we have some time for any questions, if there are any questions. See if there's any questions being raised via the comment box. Here we go. Let's have a look and scroll through there. Some good feedback on the presentation. Here we go. Let's just go to the top. Here we go. Read through and we'll go. Oh. Can't really see any significant questions on there. These are comments to a different project at the moment, or a different presentation, AI related. So, okay, so there's nothing on our comment. So I think if there are no further questions, Gareth, I think we should just round off, isn't it? And round up the presentation, or should we just go through I think a little bit more detail of what we're planning to do, or what we're planning to, Gareth?
Sure.
So at least
sure.
5 minutes left.
Yeah. Should we go back to the slide with the roadmap? Is that a good one to go back to?
Yeah.
Can you see that? Okay.
Yeah, we can see it now.
Okay.
So just to talk to you a little bit more about what we're planning this year. We've applied this. Welsh Water has applied for an Ofwat Innovation Fund project where we plan to investigate. So Ofwat has launched an innovation kind of challenge to all the water companies in the UK, and we as Welsh Water, together with Costain and the University of South Wales, have submitted a bid for that fund. And what we plan to do for that multi-million-pound project is actually build a small pilot facility at 5 Forts in North Wales, a production facility which I mentioned earlier, where we already have a biomethane to grid facility. And what we want to do with this project is really to investigate what level of impurities are there, either at the biogas state and also at the post biomethane stage, to actually help to engineer the kind of the gas treatment facilities which we need intermediate between the different stages, which Gareth mentioned earlier. So that's either in between the gas separation plant and the steam reformer, and or after the steam reformer into when we are producing and storing the hydrogen. So what we plan to do in that project is actually build a working plant using the steam reformation unit, which is already procured for a different project by the South Wales University of South Wales, but also utilizing the hydrogen vehicle fueling system they have as well, and all there to demonstrate from source to end that we can actually do this, and that will definitely help us to get some certainty around the investment that's required, because we currently have done the feasibility study around this, but we still have to get through the detailed design study, and this pilot study will help us really get a more accurate kind of like estimate of what the actual investment cost will be and what level of treatment is required in order to get the waste-derived fuel down to a very high purity, high-grade vehicle fuel hydrogen. Anything else to add?
Yeah, I think it would be, part of the value of the trial as well is to physically show converting biogas which has been derived from sewage and converting that into hydrogen, which we don't think has been done anywhere else globally. So I think that would be a really powerful thing to show. So, and then we convert the biogas into hydrogen, and then potentially we're hoping to perform a vehicle trial on that, whether it's a fuel cell vehicle for hydrogen, or whether we might look at using also looking at a dual fuel technology which combines hydrogen and diesel as a retrofit into some existing vehicles. So that could be used on one or two water company vehicles, and then sort of demonstrating that whole kind of circular economy bit where we'd be taking the waste of the waste from the sewage treatment works and using that to power vehicles that are actually being used to help provide that waste removal and treatment service. So it's a really good overall picture, and one that we've had really good reception for, and I think it's been fundamental to the way the project's been received in terms of its strong green credentials, really. Good.
Okay, I think that was a lot of time up. Thank you very much for all your attention for this and sticking with us for the last 45 minutes, including the technical glitch in the middle somewhere. And thanks for Gareth for supporting me on this particular project. Hope you enjoy the rest of the tech conference, and hope to see you in the future and to work with us.
Thanks a lot. Bye.
Cheers. Bye.
Thank you for watching. Rewatch all of our sessions online. Thank you to our partners.